These are the notes for section 8.4, special factoring. Example 1, we are just multiplying the binomials. Okay, take a look at those binomials. The first term in each one is the same, and the second term in each one is the same. One binomial has a plus sign, the second binomial has a minus sign. So let's go ahead and multiply. We're going to have x squared minus 2x plus 2x minus 4. It's going to be x squared. Negative 2x plus 2x is 0 minus 4. Okay? When we have the same number and different signs, coefficients of the x's being the same, our x term is going to equal 0. Looking at example 2, we're factoring n squared minus 36. N squared we can get by multiplying n times n. Multiplying 36, 36 is a perfect square, so we're going to have 6 and 6. To get a 0n in the middle, we are going to have a plus 6 and a minus 6. If you multiply that out, it's n squared minus 6n plus 6n minus 36, n squared plus 0 minus 36. Checks. Example 3, we're factoring 25a squared minus b squared. 25 is a perfect square, so we can do 5a times 5a to get 25a squared. To get a minus b squared, it's going to have to be b times b. To have our middle term equal 0, our signs are plus and minus. 25a squared minus 5ab plus 5ab minus b squared. It's 25a squared minus b squared, and it checks. Example 4, 8x squared minus 9. 9 is a perfect square, 3 times 3. 8 is not a perfect square. It is not factorable. We cannot factor it to have our x term in the middle equal 0. Not factorable. Example 5, factor 16x squared minus 49y squared. 16 and 49 are both perfect squares. So we're going to have 4x minus 7y times 4x plus 7y. Example 6, we're factoring x to the 4th minus 1. Multiplying to get x to the 4th, we are going to have x squared times x squared. Multiplying to 1, 1 times 1 multiplies to 1, an addition sign and a subtraction sign, x to the 4th minus 1x squared plus 1x squared minus 1. It's x to the 4th minus 1, and it checks. Okay, we'll keep going. Example 7. Please note the signs. This is different than example 1. We're going to multiply x minus 7 times x minus 7. They are both subtraction signs this time. So x squared minus 7x minus 7x plus 49. X squared minus 14x plus 49. 49 is a perfect square. 14 equals 7 plus 7. So in this case, we've got 9n squared minus 6n plus 1. 9 is our perfect square, so we're going to have 3n and a 3n. Multiplying to 1, we will have 1 and 1. To have a positive 1, we need 2 negative signs. So 3n squared times 3n squared is 9n squared minus 3n plus 1. 9n squared minus 6n plus 1. Checks. We're going to factor y squared, example 9, factor 16y squared plus 8y plus 1. And 4y plus 1 times 4y plus 1, 16y squared plus 4y plus 4y plus 1, 16y squared plus 8y plus 1. Checks. This is what it factored to. Example 10, x squared plus 20x plus 100. This one you can ask yourself what multiplies to 100 and adds to 20. And it's 10 and 10. X plus 10 times x plus 10. Example 11, we're going to factor 9x squared plus 12x plus 4. And I know that 3 times 3 is 9 and 2 times 2 is 4, so let's check it out. 3x plus 2 times 3x plus 2. Question is, does that get us 12x as our x term? If we multiply it out, it's 9x squared plus 6x plus 6x plus 4. It does get us 12x. I'm finishing up example 12 with a subtraction one again. Remember, back to the subtraction ones like example 2, we're going to have a plus sign and a minus sign in our parentheses. 9x squared minus 1, it's going to be 3x minus 1 times 3x plus 1. Checking it, 9x squared plus 3x minus 3x minus 1 does indeed equal 0 for that middle term. 9x squared minus 1, it checks. That is our factored binomial product. So the examples for section 8.4, special factoring.